Developing with JavaServer Faces Technology. Chapter 7, Using JavaServer Faces Technology in Web Pages, and Chapter 8, Using Converters, Listeners, and Validators show how to add components to a page and connect them to server-side objects by using component tags and core tags, as well as how to provide additional functionality to the components through converters, listeners, and validators. Developing a JavaServer Faces application also involves the task of programming the server-side objects, backing beans, converters, event handlers, and validators. This chapter provides an overview of backing beans and explains how to write methods and properties of backing beans that are used by a JavaServer Faces application. This chapter also introduces the bean validation feature. The following topics are addressed here: backing beans, writing bean properties, writing backing bean methods using bean validation. Backing beans. A typical JavaServer Faces application includes one or more backing beans, each of which is a type of JavaServer Faces managed bean that can be associated with the components used in a particular page. This section introduces the basic concepts of creating, configuring, and using backing beans in an application. Creating a backing bean. A backing bean is created with a constructor with no arguments like all Javabeans components and a set of properties and a set of methods that perform functions for a component. Each of the backing bean properties can be bound to one of the following: a component value, a component instance, a converter instance, a listener instance, a validator instance. The most common functions that backing bean methods perform include the following: validating a component's data, handling an event fired by a component, performing processing to determine the next page to which the application must navigate. As with all Javabeans components, a property consists of a private data field and a set of accessor methods, as shown by this code. Integer user number equal null. Public void set user number, integer user number equal user number. Public integer get user number, return user number. Public string get response. When bound to a component's value, a bean property can be any of the basic primitive and numeric types or any Java object type for which the application has access to an appropriate converter. For example, a property can be of type date if the application has access to a converter that can convert the date type to a string and back again. See writing bean properties for information on which types are accepted by which component tags. When a bean property is bound to a component instance, the property's type must be the same as the component object. For example, if a JavaX Faces component, a select Boolean component is bound to the property must accept and return a select Boolean object. Likewise, if the property is bound to a converter, validator, or listener instance, the property must be of the appropriate converter, validator, or listener type. For more information on writing beans and their properties, see writing bean properties, using the EL to reference backing beans. To bind component values and objects to backing bean properties or to reference backing bean methods from component tags, page authors use the expression language syntax. As explained in overview of the EL, the following are some of the features that EL offers. Deferred evaluation of expressions, the ability to use a value expression to both read and write data method expressions. Deferred evaluation of expressions is important because the JavaServer Faces lifecycle is split into several phases in which component event handling, data conversion and validation, and data propagation to external objects are all performed in an orderly fashion. The implementation must be able to delay the evaluation of expressions until the proper phase of the lifecycle has been reached. Therefore, the implementation's tag attributes always use deferred evaluation syntax, which is distinguished by the delimiter. To store data in external objects, almost all JavaServer Faces tag attributes use LVALUE expressions, which are expressions that allow both getting and setting data on external objects. Finally, some component tag attributes accept method expressions that reference methods that handle component events or validate or convert component data. To illustrate a JavaServer Faces tag using the EL, suppose that a tag of an application referenced a method to perform the validation of user input. Input text int equal user no value equal user number bean. User number validator equal user number bean. Validate. This tag binds the user no component's value to the user number bean. User number backing bean property by using an LVALUE expression. The tag uses a method expression to refer to the user number bean. Validate method, which performs validation of the component's local value. The local value is whatever the user enters into the field corresponding to this tag. This method is invoked when the expression is evaluated. Nearly all Java server faces tag attributes accept value expressions. In addition to referencing bean properties, value expressions can reference lists, maps, arrays, implicit objects, and resource bundles. Another use of value expressions is binding a component instance to a backing bean property. A page author does this by referencing the property from the binding attribute. Input text binding equal user number bean. User no component. In addition to using expressions with the standard component tags, you can configure your custom component properties to accept expressions by creating JAVEX. L. Value expression or JAVEX. L. Method expression instances for them. For information on the EL, see Chapter 6, Expression Language. For information on referencing backing bean methods from component tags, see referencing a backing bean method. Whitening bean properties. As explained in backing beans, a backing bean property can be bound to one of the following items: a component value, a component instance, a converter implementation, a listener implementation, a validator implementation. These properties follow the conventions of Javabeans components, also called beans. For more information on Javabeans components, see the Javabeans tutorial at http. Download. Oracle.com. Javabase. Tutorial. Javabeans. Index. HTML. The components tag binds the component's value to a backing bean property by using its value attribute and binds the component's instance to a backing bean property by using its binding attribute. Likewise, all the converter, listener, and validator tags use their binding attributes to bind their associated implementations to backing bean properties. To bind a component's value to a backing bean property, the type of the property must match the type of the component's value to which it is bound. For example, if a backing bean property is bound to a select boolean component's value, the property should accept and return the boolean value or a boolean wrapper object instance. To bind a component instance to a backing bean property, the property must match the type of component. For example, if a backing bean property is bound to a select boolean instance, the property should accept and return a select boolean value. Similarly, to bind a converter, listener, or validator implementation to a backing bean property, the property must accept and return the same type of converter, listener, or validator object. For example, if you are using the convert datetime tag to bind a datetime converter to a property, that property must accept and return a datetime converter instance. The rest of this section explains how to write properties that can be bound to component values, to component instances for the component objects described in adding components to a page using HTML tags, and to converter, listener, and validator implementations. Writing properties bound to component values. To write a backing bean property that is bound to a component's value, you must match the property tied to the component's value. Table 9-1 lists the JAVEX faces, component classes and the acceptable types of their values. Table 9-1 acceptable types of component values, component class, acceptable types of component values, input, output, a select item, a select one, any of the basic primitive and numeric types or any Java programming language object type for which an appropriate converter implementation is available. A data array of beans, list of beans, single bean, Java, SQL, result set, JAVEX, servlet, JSP, JSTL, SQL, result, JAVEX, SQL, row set a select boolean or boolean a select items Java, lang, string, collection, array, map on a select many array or list, though elements of the array or list can be any of the standard types when they bind components to properties by using the value attributes of the component tags. Page authors need to ensure that the corresponding properties match the types of the component's values. Input and output properties. In the following example, an input text tag binds the name component to the name property of a backing bean called cashier bean. Input text it equal name size equal 50 value equal cashier name. Input text. The following code snippet from the backing bean cashier bean shows the bean property type bound by the preceding component tag. Protected string name equal null. Public void set name string name this. Name equal name. Public string get name return this. Name. As described in using the standard converters, to convert the value of an input or output component, you can either apply a converter or create the bean property bound to the component with the matching type. Here is the example tag, from using datetime converter, that displays the date when items will be shipped. Output text value equal cashier. Ship date. Convert date time date style equal full. Output text. The bean property represented by this tag must have a type of Java. Util. Date. The following code snippet shows the ship date property from the backing bean cashier bean that is bound by the tag's value in the preceding example. Protected date ship date. Public date get ship date return this. Ship date. Public void set ship date ship date this. Ship date equals ship date. Data properties. Data components must be bound to one of the backing bean property types listed in table 9-1. Data components are discussed in using data bound table components. Here is part of the start tag of data table from that section. Data table it equal items. Value equal cart. Items var equal item. The value expression points to the items property of a shopping cart bean named cart. The cart bean maintains a map of shopping cart item beans. The getItems method from the cart bean populates a list with shopping cart item instances that are saved in the items map when the customer adds items to the cart, as shown in the following code segment. Public synchronized list getItems list results equal new array list. Results. Add all this. Items. Values. Return results. All the components contained in the data component are bound to the properties of the cart bean that is bound to the entire data component. For example, here is the output text tag that displays the item name in the table. Command link action equal show cart. Details. Output text value equal item. Item. Name. Command link. Select Boolean properties. Backing bean properties that hold select Boolean components data must be of Boolean or Boolean type. The example select Boolean checkbox tag from the section displaying components for selecting one value binds a component to a property. The following example shows a tag that binds a component value to a Boolean property. Select Boolean checkbox title equal bundle. Receive emails value equal custform bean. Receive emails. Select Boolean checkbox. Output text value equal bundle. Receive emails. Here is an example property that can be bound to the component represented by the example tag. Protected Boolean receive emails equal false. Public void set receive emails Boolean receive emails this. Receive emails equal receive emails. Public Boolean get receive emails return receive emails. Select many properties. Because a select many component allows the user to select one or more items from a list of items, this component must map to a bean property of type list or array. This bean property represents the set of currently selected items from the list of available items. Following example of the select many checkbox tag comes from displaying components for selecting multiple values. Select many checkbox it equal newsletters layout equal page direction value equal cashier. Newsletters. F. Select items value equal newsletters. H. Select many checkbox. Here is the bean property that maps to the value of the select many checkbox tag from the preceding example. Protected string newsletters equal new string 0. Public void set newsletters string newsletters this. Newsletters equal newsletters. Public string get newsletters return this. Newsletters. The select item and select items components are used to represent all the values in select many component. See select item properties and select items properties for information on writing the bean properties for the select item and select items components. Select one properties. Select one properties accept the same types as input and output properties, because select one component represents the single selected item from a set of items. This item can be any of the primitive types and anything else for which you can apply converter. Here is an example of the select one menu tag from displaying a menu using the H. Select one menu tag. H. Select one menu it equal shipping option required equal true value equal cashier. Shipping option. F. Select item value equal to item label equal bundle. Quick ship. F. Select item value equal 5 item label equal bundle. Normal ship. F. Select item value equal 7 item label equal bundle. Saver ship. H. Select one menu. Here is the bean property corresponding to this tag. Protected string shipping option equal to public void set shipping option string shipping option this. Shipping option equal shipping option. Public string get shipping option return this. Shipping option. Note that shipping option represents the currently selected item from the list of items in the select one component. The select item and select items components are used to represent all the values in select one component. This is explained in the section displaying a menu using the H. Select one menu tag. For information on how to write the backing bean properties for the select item and select items components, see select item properties and select items properties. Select item properties. A select item component represents a single value in a set of values in a select many or a select one component. A select item component must be bound to a backing bean property of type JavaX. Faces. Model. Select item. A select item object is composed of an object representing the value, along with two strings representing the label and description of the select item object. The example select one menu tag from displaying a menu using the H. Select one menu tag contains select item tags that set the values of the list of items in the page. Here is an example of a bean property that can set the values for this list in the bean. Select item 1 equal null. Select item get item 1 return item 1. Void set item 1 select item 1 equal item. Select items properties. Select items components are children of select many and select one components. Each select items component is composed of a set of either JavaX. Faces. Model. Select item instances or any collection of objects, such as an array, a list, or even POJOs. This section explains how to write the properties for select items tags containing select item instances. You can populate the select items with select item instances programmatically in the backing bean. In your backing bean, create a list that is bound to the select item component. Define a set of select item objects, set their values, and populate the list with the select item objects. The following example code snippet from a backing bean shows how to create a select items property. Import JavaX. Faces. Model. Select item. Protected array list options equal null. Protected select item newsletter O equal new select item 200 Dukes quarterly. In constructor, populate the list options. Add newsletter O. Options. Add newsletter 1. Options. Add newsletter 2. Public select item get newsletter O return newsletter O. Void set newsletter O select item first NL newsletter O equal FIRSTNL. Other select item properties public collection get options return options. Public void set options collection options this. Options equal new array list options. The code first initializes options as a list. Each newsletter property is defined with values. Then each newsletter select item is added to the list. Finally, the code includes the obligatory set options and get options accessor methods. Whitening properties bound to component instances. A property bound to a component instance returns and accepts a component instance rather than a component value. The following components bind a component instance to a backing bean property. H. Select boolean checkbox it equal fan club rendered equal false binding equal cashier. Special offer. H. Output label for equal fan club rendered equal false binding equal cashier. Special offer text. H. Output text it equal fan club label value equal bundle. Duke fan club. H. Output label. The select boolean checkbox tag renders a checkbox and binds the fan club a select boolean component to the special offer property of cashier bean. The output label tag binds the fan club label component, which represents the checkbox's label, to the special offer text property of cashier bean. If the user orders more than $100 worth of items and clicks the submit button, the submit method of cashier bean sets both components rendered properties to true, causing the checkbox and label to display when the page is re-rendered. Because the components corresponding to the example tags are bound to the backing bean properties, these properties must match the components types. This means that the special offer text property must be of type output, and the special offer property must be of type select boolean. Output special offer text equal null. Public output get special offer text return this. Special offer text. Public void set special offer text output special offer text this. Special offer text equals special offer text. A select boolean special offer equal null. Public a select boolean get special offer return this. Special offer. Public void set special offer a select boolean special offer this. Special offer equals special offer. For more general information on component binding, see backing beans. For information on how to reference a backing bean method that performs navigation when a button is clicked, see referencing a method that performs navigation. For more information on writing backing bean methods that handle navigation, see writing a method to handle navigation. Writing properties bound to converters, listeners, or validators. All the standard converter, listener, and validator tags included with JavaServer faces technology support binding attributes that allow you to bind converter, listener, or validator implementations to backing bean properties. The following example shows a standard convert datetime tag using a value expression with its binding attribute to bind the datetime converter instance to the convert date property of log in bean. H. Input text value equal log in bean. Birth date. F. Convert date time binding equal log in bean. Convert date. H. Input text. The convert date property must therefore accept and return a datetime converter object, as shown here. Private datetime converter convert date. Public datetime converter get convert date. Return convert date. Public void set convert date datetime converter convert date. Set pattern EEOE 3000 DDE. This. Convert date equal convert date because the converter is bound to a backing bean property. The backing bean property can modify the attributes of the converter or add new functionality to it. In the case of the preceding example, the property sets the date pattern that the converter uses to parse the user's input into a date object. The backing bean properties that are bound to validator or listener implementations are written in the same way and have the same general purpose. Writing backing bean methods. Methods of a backing bean can perform several application-specific functions for components on the page. These functions include performing processing associated with navigation, handling action events, performing validation on the component's value, handling value change events. By using a backing bean to perform these functions, you eliminate the need to implement the validator interface to handle the validation or one of the listener interfaces to handle events. Also, by using a backing bean instead of a validator implementation to perform validation, you eliminate the need to create a custom tag for the validator implementation. In general, it's good practice to include these methods in the same backing bean that defines the properties for the components referencing these methods. The reason for doing so is that the methods might need to access the component's data to determine how to handle the event or to perform the validation associated with the component. The following sections explain how to write various types of backing bean methods. Writing a method to handle navigation. An action method, a backing bean method that handles navigation processing, must be a public method that takes no parameters and returns an object, which is the logical outcome that the navigation system uses to determine the page to display next. This method is referenced using the component tag's action attribute. The following action method is from a backing bean named cashier bean, which is invoked when a user clicks the submit button on a page. If the user has ordered more than $100 worth of items, this method sets the rendered properties of the fan club and special offer components to true, causing them to be displayed on the page the next time that page is rendered. After setting the component's rendered properties to true, this method returns the logical outcome null. This causes the JavaServer faces implementation to re-render the page without creating a new view of the page, retaining the customer's input. If this method were to return purchase, which is the logical outcome to use to advance to a payment page, the page would re-render without retaining the customer's input. If the user does not purchase more than $100 worth of items, or if the thank you component has already been rendered, the method returns receipt. The JavaServer faces implementation loads the page after this method returns. Public string submit. If cart. Get total. 100. Special offer. Is rendered special offer text. Set rendered true. Special offer. Set rendered true. Return null, else if special offer. Is rendered. Thank you. Is rendered thank you. Set rendered true. Return null, else clear. Return receipt. Typically, an action method will return a string outcome, as shown in the previous example. Alternatively, you can define an enum class that encapsulates all possible outcome strings and then make an action method return an enum constant, which represents a particular string outcome defined by the enum class. The following example uses an enum class to encapsulate all logical outcomes. Public enum navigation main, account hist, account list, ATM, ATM ACK, transferred funds, transfer ACK, error. When it returns an outcome, an action method uses the dot notation to reference the outcome from the enum class. Public object submit. Return navigation. Account hist. The section referencing a method that performs navigation explains how a component tag references this method. The section writing properties bound to component instances explains how to write the bean properties to which the components are bound. Writing a method to handle an action event. A backing bean method that handles an action event must be a public method that accepts an action event and returns void. This method is referenced using the component tag's action listener attribute. Only components that implement JavaX faces component action source can refer to this method. In the following example, a method from a backing bean named localBean processes the event of a user clicking one of the hyperlinks on the page. Public void choose locale from link action event string current equal event. Get component. Get it. Faces context equal faces context. Get current instance. Context. Get view root. Set locales. Get current. This method gets the component that generated the event from the event object. Then it gets the component's Idaho, which indicates a region of the world. The method matches the Idaho against a hash map object that contains the locales available for the application. Finally, the method sets the locale by using the selected value from the hash map object. Referencing a method that handles an action event explains how a component tag references this method. Writing a method to perform validation. Instead of implementing the validator interface to perform validation for a component, you can include a method in a backing bean to take care of validating input for the component. A backing bean method that performs validation must accept a face's context, the component whose data must be validated, and the data to be validated, just as the validate method of the validator interface does. A component refers to the backing bean method by using its validator attribute. Only values of input components or values of components that extend to input can be validated. Here is an example of a backing bean method that validates user input. Public void validate email faces context I component to validate object value string message equal string email equals string value if email contains semicolon new input to validate set valid false message equal coffee break bean load error message context coffee break bean CB resource bundle name email error context add message to validate get client id context new faces message. Take a closer look at the preceding code segment. The validate email method first gets the local value of the component. The method then checks whether the character is contained in the value. If not, the method sets the component's valid property to false. The method then loads the error message and queues it onto the face's context instance, associating the message with the component id. See referencing a method that performs validation for information on how a component tag references this method. Writing a method to handle a value change event. A backing bean that handles a value change event must use a public method that accepts a value change event and returns void. This method is referenced using the component's value change listener attribute. This section explains how to write a backing bean method to replace the value change listener implementation. The following example tag comes from registering a value change listener on a component, where the h input text tag with the id of name has a value change listener instance registered on it. This value change listener instance handles the event of entering a value in the field corresponding to the component. When the user enters a value change event is generated, and the process value change event method of the value change listener class is invoked. H input text id equal name size equal 50 value equal cashier. Name required equal true. F value change listener type equal listeners. Name changed. H input text. Instead of implementing value change listener, you can write a backing bean method to handle this event. To do this, you move the process value change event method from the value change listener class, called name changed, to your backing bean. Here is the backing bean method that processes the event of entering a value in the name field on a page. Public void process value change event throws the board processing exception if null. Equal event. Get new value faces context. Get current instance. Get external context. Get session map. Put name, event. Get new value. To make this method handle the value change event generated by an input component, reference this method from the component tag's value change listener attribute. See referencing a method that handles a value change event for more information. Using bean validation. Validating input received from the user to maintain data integrity is an important part of application logic. Validation of data can take place at different layers in even the simplest of applications, as shown in the guess number example application from an earlier chapter. The guess number example application validates the user input in the h input text tag for numerical data at the presentation layer and for a valid range of numbers at the business layer. Javabeans Validation. Bean validation is a new validation model available as part of Java EE6 platform. The bean validation model is supported by constraints in the form of annotations placed on a field, method, or class of a Javabeans component, such as a backing bean. Constraints can be built in or user-defined. User-defined constraints are called custom constraints. Several built-in constraints are available in the JavaX Validation Constraints package. Table 9-2 lists all the built-in constraints. Table 9-2 Built-in bean validation constraints. Constraint description example. Assert false. The value of the field or property must be false. Assert false. Boolean is unsupported. Assert true. The value of the field or property must be true. Assert true. Boolean is active. Decimal max. The value of the field or property must be a decimal value lower than or equal to the number in the value element. Decimal max 30. Big decimal discount. Decimal min. The value of the field or property must be a decimal value greater than or equal to the number in the value element. Decimal min 5. Big decimal discount. Digits. The value of the field or property must be a number within a specified range. The integer element specifies the maximum integral digits for the number, and the fraction element specifies the maximum fractional digits for the number. Digits integer equals 6, fraction equal 2. Big decimal price. Future. The value of the field or property must be a date in the future. Future date. Event date. Max. The value of the field or property must be an integer value lower than or equal to the number in the value element. Max 10 in quantity. Min. The value of the field or property must be an integer value greater than or equal to the number in the value element. Min 5 in quantity. Not null. The value of the field or property must not be null. Not null. String username. Null. The value of the field or property must be null. Null string. Unused string. Past. The value of the field or property must be a date in the past. Past date. Birthday. Pattern. The value of the field or property must match the regular expression defined in the regexp element. Pattern regexp equal D3. D3. D4 string phone number. Size. The size of the field or property is evaluated and must match the specified boundaries. If the field or property is a string, the size of the string is evaluated. If the field or property is a collection, the size of the collection is evaluated. If the field or property is a map, the size of the map is evaluated. If the field or property is an array, the size of the array is evaluated. Use one of the optional max or min elements to specify the boundaries. Size min equal 2, max equal 240. String brief message. In the following example, a constraint is placed on a field using the built-in not null constraint. Public class name. Not null private string first name. Not null private string last name. You can also place more than one constraint on a single Javabeans component object. For example, you can place an additional constraint for size of field on the first name and the last name fields. Public class name. Not null. Size min equal 1, max equal 16. Private string first name. Not null. Size min equal 1, max equal 16. Private string last name. The following example shows a method with a user-defined constraint that checks for a predefined email address pattern such as a corporate email account, valid email, public string, get email address, return email address. For a built-in constraint, a default implementation is available. A user-defined or custom constraint needs a validation implementation. In the above example, the valid email custom constraint needs an implementation class. Any validation failures are gracefully handled and can be displayed by the H messages tag. Any backing bean that contains bean validation annotations automatically gets validation constraints placed on the fields on the JavaServer Faces application's web pages. See validating persistent fields and properties for more information on using validation constraints. Validating null and empty strings. The Java programming language distinguishes between null and empty strings. An empty string is a string instance of 0 length, whereas a null string has no value at all. An empty string is represented as it is a character array of 0 characters. A null string is represented by null. It can be described as the absence of a string instance. Backing bean elements represented as a JavaServer Faces text components such as input text are initialized with the value of the empty string by the JavaServer Faces implementation. Validating these strings can be an issue when user input for such fields is not required. Consider the following example, where the string test string is a bean variable that will be set using input typed by the user. In this case, the user input for the field is not required. If test string equals null, do something, else do another thing. By default, the do another thing method is called even when the user enters no data, because the test string element has been initialized with the value of an empty string. In order for the bean validation model to work as intended, you must set the context parameter JavaX. Faces. Interpret empty string submitted values as null to true in the web deployment descriptor file, web. XML. Context param name, JavaX. Faces. Interpret empty string submitted values as null. Param name, param value. True. Param value, context param. This parameter enables the Java server faces implementation to treat empty strings as null. Suppose, on the other hand, that you have a not null constraint on an element, meaning that input is required. In this case, an empty string will pass this validation constraint. However, if you set the context parameter JavaX faces, interpret empty string submitted values as null to true, the value of the backing bean attribute is passed to the bean validation runtime as a null value, causing the not null constraint to fail.